My name is Joe Bartlett, and I shall try my best to make this new alternative energy presentation as simple as possible, starting with some basic facts and progressively lead into how I arrived at the final design. Here we have the gravity acting on oceans, inland seas and reservoirs. This gravity creates hydrostatic water pressure. For example, if we come down 231 feet in ocean depth, this will give us 100 pounds per square inch water pressure. Now if we went down and continued to 462 feet, that would give us 200 pounds per square inch water pressure. Now how can we utilise this water pressure? If we place two single-acting hydraulic cylinders under the ocean at 231 feet depth, it will give us 100 pounds per square inch, which then acts against the 4 square inch piston area, forcing the smaller 1 square inch piston across, thus giving us 400 psi higher pressure. So we have produced 400 pounds per square inch from a 100 pound per square inch supply pressure. How can a return stroke be achieved so that we can achieve a recycling action to give us a continual 400 pound per square inch pressure? Do we add another hydraulic single-acting cylinder of the same size in line on the other side? Then we will not get a return action because both areas are the same and therefore we have equal forces and there's zero action. We can go to a larger cylinder. If we go to a larger cylinder, it will return. However, then we still have the same problem when we wish to recycle back. What if we vary large and small diameter hydraulic cylinder strokes and we add two small circuits? Only this time all our cylinders are double fluid acting against each surface of the large and small pistons. Again, the pistons will not move because of equal pressures acting against both surfaces of the large and small pistons. We shall have to rethink and start considering areas, volumes, strokes and pressures to achieve our resultant forces. Now if we have two syringes connected and we push on the larger syringe, which is 4 square inches with a 1 square inch stroke, fluid will travel through into the 1 square inch syringe coming over this side and fill up the 1 square inch cylinder, and we find that our stroke results in a 4 inch stroke. So the fluid has been displaced from the larger area into the smaller area. How can we now incorporate volume transfer and piston stroke involving pistons of unequal area and the same stroke into a design which will give us a force resulting from gravity? If we have the ocean pressure coming in, acting against a larger cylinder, it will only move a very small distance, as it is physically impossible to get 16 cubic inches into 4 cubic inch cylinder with or without a connecting rod between the pistons. Now, can we decrease the stroke of the large piston areas and multiply the number 4 times in series, still in direct line with the small slave cylinder area, to get our hydraulic force? The first 3 cylinders, 1, 2, 3, shall be rodless, double acting, and the last one we end up having a single acting cylinder with a rod direct acting onto the small slave cylinder. With our ocean pressure acting against the large piston area, will force that piston through, displacing the fluid on the other side into the next cylinder, which in turn forces that piston across, displaces this fluid pressure around into the next cylinder, acts against the next large piston area, which then displaces the following fluid through against the piston area here, which forces the rod and the small piston area outwards. However, this will only displace 1 inch stroke of fluid out into our high pressure side. The reason being because each of the large cylinders have a 1 inch stroke each. Here we have achieved movement, resulting in a higher pressure incorporating rodless and pistons with a rod. Also single and double acting pistons. How can we achieve a full 4 inch stroke on both large and small piston areas? If we then turn to the large piston areas and incorporate a telescopic cylinder arrangement instead of the 4 large piston areas in line, we should be able to achieve this. We shall have the outer telescopic cylinder fixed into position with 1, 2, 3, 4 piston areas and incorporated into a piston cylinder arrangement. With our ocean system pressure acting against the outer piston, this will force fluid on the other side in turn to act against the next inner piston. Once again, fluid travels against and acts against the next piston, which in turn forces against our rodless piston, all which results in an action which forces against our small cylinder area, the slave cylinder, forcing the piston outwards, giving us 400 psi. Now, with our ocean pressure coming in and acting against the outer cylinder piston, instantaneously it forces fluid pressure through, acting against all 3 pistons, which in turn gives us a 4 inch, a complete 4 inch stroke coming out. Thus we have a complete 4 inch stroke on our small piston area here. Because we have vented the front of this piston, we have a pressure differential of 100 psi to equivalent of atmospheric pressure, thus giving or allowing us to achieve a force outwards. Now, how can we achieve a return stroke on this unique telescopic hydraulic piston design? We can do this by fitting the same telescopic piston design here across to the other side, in line with the small piston area. Also, we have fitted a 5-port 2-position directional control valve with appropriate piping to enable continuous recycling of this unique system. The directional control valve allows ocean pressure supply in and through to the outer piston of the left-hand side assembly here, which instantaneously forces the outer piston through the rest and to the inner piston, which then acts against our smaller area slave piston cylinder, which forces fluid out at a higher pressure. We find as the left-hand side hydraulic telescopic cylinder piston assembly extends outwards, the right-hand side hydraulic telescopic piston assembly will retract. Now, when this telescopic cylinder assembly retracts, we must displace fluid behind number 4 piston, which then will travel back through the directional control valve to the rear side behind the smaller slave cylinder piston. This is possible to displace the fluid behind number 4 piston around to the other side behind the slave cylinder piston, because as we saw before, with a shorter stroke of example 1 inch here with a 4 cubic inch volume, we could fill up a 1 square inch by 4 inch long cylinder equally. With our directional control valve, at the end of each stroke it would be either mechanically or electrically actuated to allow, say, continual recycle of this whole design. Now if we want to stop or start the design on the pressure inside or the high pressure outside of the system, we can fit ball valves or stop valves in the system to enable stop and starting. Now we have achieved another means of harnessing an extremely efficient, continuous, alternate energy made possible by gravity acting on our oceans, inland seas and reservoirs, causing hydrostatic fluid pressure. This presentation has shown a simple, basic way to supply energy previously not shown anywhere. We also have a design where this system may be used independently anywhere in the world. Thank you very much for your attention.